Talk Maths.
Okay, in this video we're going to be looking at the standard form. First, let's have a reminder of looking at powers. So if we have 10 to the power 2, that's 10 squared, 10 times 10, which would be 100. 10 to the power 3 would be 10 cubed, 10 times 10 times 10, which would be 1,000. 10 to the 5 would be 10 to the power of 5. 10 times 10 times 10 times 10 times 10. So now we've just revised over powers. Let's look at what standard form actually is. Standard form is a way that we can write really large or really small numbers in powers of 10 to make them easy to read and compare. Now I've written here an example. We have got the number 2 million, and I've written that as 2 times 1 million, which of course it is, 2 times 1 million. When we're writing in standard form, we take a number from our original number that is between 1 and 10. It must be less than 10, but between 1 and 10, and we times it by the powers of 10. Well, this is times by a million, which is 10 to the 6. So if we have a look at our final answer here, we can see that I've written the answer as 2 times 10 to the power 6. Now this is because I made the 2 my initial number, which was between 1 and 10, and when I did that it meant that the decimal point was here. Well, really in my number the decimal point's at the end, so I have to see how many times to the power of 10 bigger it is, and I can see 1, 2, 3, 4, 5, 6. So that's 2 times 10 to the power 6. Okay then, so let's have a look now at this number, 345,000. So we write the number as a number greater than 1 and less than 10, as I've previously said, and then we have to write that to the correct power of 10. Well, we've got 345,000. I'm going to write it as 3.45 and then do it to the correct power of 10. So if we look at this, we can see that to get to our original place where the decimal was, right at the end, we had to times by, there's 1 there, 2, 3 powers of 10, 4 powers of 10, 5 powers of 10. So this number is written as 3.45 times 10 to the 5. Okay, and then when we put the 10 to the 5, multiply this by 10 to the 5, we get back to our original number. So let's have a couple of examples. Here we have 120 million. Okay, so where would I put the decimal in the standard form? I would put it here. 1.2 is a number between 1 and 10. Okay, so having done that, I then need to see how many times the decimal would have to move to get back to where it originally was. And it goes 1, 2, 3, 4, 5, 6, 7, 8 times. So if I move this, there's my number 1.2 times 10 to the 8. It's actually had to move 8 times. It's 10 to the power 8. Here, 432,000. Okay, I'm going to find my number between 1 and 10, and I'm going to put my decimal there. So I'm going to go 4.32. How many times do I have to move my decimal point to get it back to where it started? Well, it would be 1, 2, 3, 4, 5. So this number written in standard form will be 4.32 times 10 to the 5. Now when we look at these, we can look at the powers of 10 and instantly know that this number is smaller than this number, because this is 10 to the power 8. Although it's only 1.2, it's to the power 10 times 10 to the power 8, whereas this is only times 10 to the power 5. Now, as I mentioned earlier, we can use smaller numbers, look at small numbers and alter these by dividing them by powers of 10. So this is a very very small number here. Look, if we look where the decimal point is at the moment, I'm going to put the decimal point here. So I've still got a number between 1 and 10. I've got the number 6.2, but this time to divide it. So let's go backwards and see how far we go to get to our original decimal place. So 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, so in this case, we still write 6.2 times 10, but this time we've been dividing by powers of 10, so we have to write -8 so that we know that it's that many times smaller. And on this one, look, we've got 0.00037. I'm going to put my decimal here, 3.7. So my number between 1 and 10 is 3.7. And I'm going to obviously be working with a -10. So I'm going to see how many times I have to go backwards to reach my initial decimal place, which is 1, 2, 3, 4 times. So let's have a look under the box here, and we can see 3.7 is the number between 1 and 10 times 10, but this time to the -4. Okay, so that's a brief look through standard form. It's the kind of way that scientists would write numbers, and it clearly shows us how we can look and see the size difference. Okay, this is -8, so this number is much smaller this time than this number because it's risen to the power of -8.